In this tutorial, I will perform a multivariate spatial analysis. Then I will apply a classification scheme to the multi-scale domains. I will use a clustering algorithm to determine how to divide my data into categories for the classification. I will be using the Artemis dataset. First, I will upload the dataset. You can see that this dataset contains only a subset of 6 variables from the full multi-element dataset, and that they have been transformed using the additive log ratio method, also known as the ALR, with titanium as the denominator. I select all the variables and upload the dataset. In the Analyze window, I select Perform Multivariate Analysis and then the blue Analyze button. Now you can see that both the univariate and multivariate tabs are active. Select the Multivariate tab. There are several panels in the Multivariate tab. Work through these in order from the top down. First, select the Boundaries panel. This panel allows us to plot the results of the spatial analysis prior to applying a classification. At this stage, the Mosaic plot can be left uncoloured, or you can colour by total variance of all variables within each domain. Select one drill hole to plot. In this dataset, there is only one drill hole. I leave the Mosaic plot uncoloured and choose to show the signal legend. Then I select the dark blue Plot Boundaries button. The plots appear in the image viewer. On the left are all the variables. They have been scaled to fit in a single plot, and there is a legend. The middle plot shows all the boundaries for these variables combined. And the right-hand plot shows the multi-scale Mosaic plot, where the boundaries have been used to divide the drill hole into domains. In the next panel, we are going to apply a multivariate classification to this plot. We select the Classification panel. This panel allows us to run a clustering algorithm on our data. The results of clustering algorithms are not always ideal for geological data. However, they are very useful for a first-pass analysis of the data. A number of clustering algorithms have been implemented here. You can experiment with these. I'm going to choose the agglomerative clustering algorithm. You can also set the number of clusters. I choose 8 and then press the Set button. Next, you can choose the colours for your cluster analysis. Each cluster will have a different colour. Once again, you can randomize the colours using the Random Colour button, or you can select individual colours and edit manually. Now run the classification using the dark blue Run Classification button. Once the classification has run, we can view the results in 2D scatter plots. To get an idea of how well it worked, go to the scatter plot plane. LDA stands for Linear Discriminant Analysis. This is a projection of the high-dimensional data onto a 2D plot, using a linear projection that best separates the clusters. We choose the dark blue scatter plot button. On this plot, we can see a reasonable separation of the clusters in space. Unfortunately, the axes have no obvious geological meaning, so now we move on to more conventional 2D scatter plots. We choose two variables, and then we choose the variables that we want to plot. In this case, I have chosen chromium and zirconium because I know these are good at distinguishing the various rock types. Then I choose plot scatter plot. You should inspect the resulting scatter plot. You can plot as many scatter plots as you like. You may decide to rerun the classification with a different number of clusters or with a different algorithm until you get a cluster result that you're satisfied with. Next, we will apply this classification to the multiscale domains of the Mosaic plot. Select the Mosaic panel, select the drill hole, and then choose the Plot Mosaic button. On the left-hand side, the plot shows all the input variables plotted down hole. They have been scaled to fit within one plot. In the middle is the classification applied to each sample. And on the right is the classification applied to the domains. We can see a number of very distinct rock units at a scale of approximately 20. The results from the sample classification indicate that some of these units had quite variable composition. Note that there is a blue button in the bottom left-hand part of the Mosaic panel. This allows you to change the colours and names of the clusters. If you click on it, it brings up a pop-up window where you can edit the names, and the colours. And then we use Update Clusters. To see the new colours or the names, you'll have to replot by choosing the Plot Mosaic button. You can also replot the scatter plots. You can see that it has updated the name. I can now choose a suitable scale for my new lithogeochemical log and plot it using the Pseudo log panel. I want to draw a regional scale cross-section through the drill holes in this area, so I will choose a relatively large scale of 20 because this captures some of the stable large-scale lithogeochemical units. Choose the Pseudo logs panel. I've typed in the scale and selected a plot width and height. And then I select the dark blue Plot Pseudo log button. I can inspect the result in the image viewer. If the resulting log is satisfactory for my purposes, I can now export the results. Prior to exporting, I can select some export options. These options allow me to capture extra information about the rock type classes, which can be extracted from the Mosaic plot due to its hierarchical structure. Let me show you. I will choose to export 3 columns. This will export not only the dominant lithogeochemical rock type in the unit, but also the subtypes from the smaller scales. I will also select the Include Percent columns. This will tell me what percentage of the domain is occupied by each sub-rock type. The reason we have these information-rich export options is that when you're dealing with large-scale geological units, they are typically packages of rock units where you've grouped similar rock types that are spatially connected. In this case, a single label may provide insufficient information or incorrect labeling. Now select the Export Pseudo log button. I can open the file. The file contains the hole ID, the depth from and depth to of the intervals at the scale of 20. In the first row, we can see that the dominant rock type, lith 1, was rock 6, and that 81% of this unit was rock 6. The unit also contains minor amounts of rock 2 and rock 1. In some rows we can see that the first rock is 100%. This method of structuring the file is designed to mimic the way geologists log when they are grouping rock types. You can import this file directly into your geological modelling software in the same way that you would import any geology log. In future, we will be incorporating other classification systems into the web app, including supervised machine learning. This concludes this tutorial. I hope you have found it useful.